All right, Chapter 1, A Grand Tour of the Heavens. This video, we're just going to quickly go over information from Chapter 1, Section 1, Peering Through the Universe, a Time Machine. Basically, I just want to make sure you understand the big points that were mentioned in this section. The big thing, really, the first thing we want to talk about is that we know the universe is very, very old, right? 14 billion years. It formed about 14 billion years ago. And we'll talk later about how we know the age of the universe, how we're able to calculate those things. You know, we don't just pull that information out of a hat. We don't just say, well, you know, it'd be nice if it was this old because, you know, that's what we'd like it to be. We have evidence that tells us that. You know, we have evidence that suggests the universe has to be about that age. But we'll talk about that evidence later on in the course. But one thing I do want you to consider with this, you know, we accept, based on the evidence that the universe began about 14 billion years ago, is the idea that, you know, humans, as long as we've been around, really that's not that long in the cosmic time scale. Now, there is a video that I put a link to from YouTube onto the class website that shows, it kind of gives you a feel for that. It takes, it's from Carl Sagan's Cosmos series, and it takes a regular calendar and kind of compresses the history of the universe into a regular calendar. And so it gives you some idea of the scale of the universe based on a regular calendar. It gives you some idea to think about. In this illustration, you're kind of looking at a number line, and you're saying, you know, with this number line, you know, how far back have we gone into the history of the universe. Okay, so it's very kind of similar thing. The graphics, you know, it kind of gets you to the same kind of thing. All right, so the idea that humans have not been around very long on the cosmic scale of things, all of recorded history is a very tiny part of the history of the universe. All of humanity's recorded history. All right, the reason that one of the things that's neat about astronomy is that, you know, we can see things as they appeared a long time ago. If you study other sciences where you're looking back into the past, you know, we have to infer what things look like in the past. But in astronomy, we don't have to. And the reason for that is because light has a finite speed. Light is not infinite in speed. It has a speed limit. It travels at about 186,000 miles per second. And so, you know, we know that when we look at things that are very far away, we can't be seeing them as they are right now. We're seeing them as they looked in the past. And the further away they are from us, the further in the past we are seeing them. So, for instance, you know, if I'm looking across the room and somebody's, you know, 10 or 20 feet from me, then I'm seeing them as they looked about a billionth of a second or 2 billionths of a second in the past, because that's how long it took for the light to get to me. But the further away we go, the further back in time I'm seeing. If I look to the moon, it's about a second. I'm seeing it as it was about a second ago. So there's not much difference between the way it appears now and the way it appeared a second ago. The sun, it's about 8 minutes away. Further out into the solar system, you know, we're going to get into 40 minutes, 50 minutes, an hour. When we start going back into stars, you know, we start looking at stars, we're looking years away. The closest star to us is over 4 light years away. So it took that light over 4 years for us to reach us. So when we see even the closest stars, we're seeing them as they appeared over 4 years ago. And there's not even that many stars that are that close. Many stars, even in our own Milky Way galaxy, are thousands of light years away from us. You know, so the light that we're seeing took thousands of years or tens of thousands of years to get to us. Okay, and that's just in our own galaxy. If we look to things beyond our galaxy, we're seeing things into the millions or the billions of years ago as they appeared. All right, so, you know, if we're looking at the galaxy, thousands, tens of thousands of years. If we look out beyond the Milky Way galaxy, we can see objects that are billions of years in the past. Okay. So our view of the universe is a view into the past. And that's when we talk about peering through the universe and we talk about it being a time machine. That's what we mean. When we see events or when we see things in the sky, we're seeing them as they appeared in the past. And the further away they are, the more distant past we're talking about. All right? We'll spend some time in a later chapter talking about different kinds of telescopes and how our telescopes can allow us to study things better than we could have in the past. Improving technology with ground-based telescopes and with space-based telescope platforms allows us to see more detail or to see further away than we could in the past. All right. So something to keep in mind whenever we talk about these things, we're actually going to be considering things like, well, here's what it looked like in the past, but what's happened since then? If we're seeing it as it was billions of years ago, what does it look like now? Does it still exist? How has it changed? What's going on? And that's one of the really great things about astronomy is that, we're figuring these things out continuously. And we can do that because we can see objects that are very similar in structure that are different distances away. So we can kind of say, well, this object must have evolved into this kind of object, or something along those lines. Okay? So, big ideas from this section is that we can learn about the universe by looking into its past. We look into its past by looking out into the universe. Because light has a finite speed, that we don't see things as they are today. We see them as they were in the past. Those observations tell us about what we're seeing today, as well as what the universe was like long into the past. So it's almost like, rewinding a movie. The further out we look, the further back we rewound the movie. Okay? And from those observations, we learn about the universe and we construct our theories about it. We take that evidence and we learn what the universe is like. And so that's really where, the big thing we're going to go with in this text. We're going to be looking at the universe, and based on what we see and what we found, what does all this mean? All right, so that is Chapter 1, Section 1, Peering Through the Universe, a Time Machine.